So, let's go. Number 1. Rongorongo. Picture the most isolated speck of inhabited land on the planet. Rapa Nui, the island we call Easter Island, sits roughly 3,500 kilometers off the coast of Chile, surrounded by open ocean in every direction. And on that island, carved into slabs of dark wood, is a script that nobody alive can read. The name Rongorongo means, in the local language, to recite, or to chant out. It is a cruel name because the chanting stopped more than a century ago, and we have never gotten it back. Only about 25 or 26 genuine objects survive anywhere in the world. They are scattered across museums in Rome, Santiago, Berlin, Vienna, London, Washington, and Honolulu. Together, they hold somewhere around 15,000 individual glyphs. The signs are tiny, tightly packed outlines of birds, fish, plants, and human figures, with one frigate bird shape appearing again and again. They were cut into Toramiro wood using shark teeth and flakes of obsidian by hands that knew exactly what they were doing. Here's the first strange feature. The text is written in what scholars call reverse boustrophodon. You read one line from left to right. Then, to read the next line, you physically turn the entire tablet upside down. The lines alternate direction, and every other one is literally inverted. Imagine a book you have to rotate after every sentence. That is Rongorongo. When the Dutch Admiral Jacob Roggeveen made contact in 1722, no visitor recorded anyone reading these tablets. The first European to even mention them was a French missionary named Eugène Hérault in 1864. He noted that the tablets sat in nearly every house, and yet the islanders no longer seemed to read them. Something had already been lost. What happened next sealed the silence. Between 1862 and 1863, Peruvian slave raiders abducted as many as 1,500 people from Rapa Nui, including the king and much of the learned class. Disease and failed repatriation followed. The population, which had numbered in the thousands, collapsed to around 110 people by 1877. The people who could read the tablets were gone, and they took the key with them. That has not stopped people from trying. A Rapa Nui man named Matoro chanted readings for Bishop Yausen in 1873, but his recitations were inconsistent and are now considered unreliable. In 1995, the linguist Stephen Roger Fisher announced that one long text, the Santiago staff, encoded repeated formulas of creation, one thing joining with another to produce a third. Most specialists reject the reading. Russian scholars, including Boris Kudryavtsev and later Yuri Knorozov, the same man who helped crack the Maya glyphs, did identify passages that repeat across different tablets, which proves there is real structure here. A few fragments hint at meaning. The tablet known as Mamari appears to contain a lunar calendar. The scholar Konstantin Pozniakov counted a working inventory of around 52 to 55 basic signs, which suggests a syllabary, where each sign stands for a sound. But a deeper question remains unsettled. Is Rongorongo true writing that records a spoken language, or is it a memory aid, a set of prompts for chants already known by heart? Some argue the script was invented only after islanders watched the Spanish sign an annexation document in 1770. If that is true, Rongorongo may be one of the few times in history we can almost watch a people invent writing from scratch. And we still cannot read a word of it. Number 2. The Cascajal Block. From an island at the edge of the world, we moved to a gravel quarry in Mexico, and to an object that nearly ended up in a road builder's spoil heap. In 1999, workers quarrying gravel near the village of Lomas de Tacamachapa in the Mexican state of Veracruz pulled a heavy stone slab out of the ground. It was mixed in with broken pottery and pieces of clay figurines. Nobody excavated it carefully. It simply came up with the gravel. That stone is now considered the oldest writing in all of the Americas. The Cascajal Block is a slab of serpentinite weighing about 12 kilograms, roughly 26 pounds, and measuring around 36 centimeters long. Carved into one face are 62 signs, made up of 28 distinct glyph types, some repeated. In 2006, a team published the block in the journal Science. The authors included Maria del Carmen Rodriguez Martinez, Ponciano Ortiz, and the Maya specialists Stephen Houston and Carl Taub. Pottery found in the same context dates the find to around 900 BCE, in what archaeologists call the San Lorenzo phase of the Olmec civilization. The Olmec are often called the mother culture of Mesoamerica, the people whose ideas echoed through the later Maya and Aztec worlds. And here, on this block, is their writing, centuries older than any other script known from the Americas. The signs include shapes resembling corn, insects, fish, and throne-like forms, several of which match motifs already known from Olmec art. What convinced the researchers this was genuine writing rather than decoration is the pattern. The signs are arranged horizontally, in something like lines. Certain sequences repeat. The text seems to reset and start again, the way real writing returns to the margin. Repeated pairs of signs hint at a structure like a name followed by a title. The surface itself appears to have been smoothed and reused, which suggests the block may have been a kind of reusable writing slate. But there is no way to read it. There is no descendant script that carried these signs forward. There is no bilingual text, no Rosetta Stone that pairs the Cascajal signs with a language we know. The presumed language behind it is an early form of Mixozoquian, still spoken in the region, but that is an educated guess, not a translation. Worse, the block was not found in a controlled dig, so some scholars question how much weight it can bear at all. And because the signs are laid out horizontally, unlike the columns of later Mesoamerican scripts, the block cannot even be compared cleanly to the Isthmian or Zapotec writing that came afterward. It stands alone, a single object, which means the statistical tools that crack scripts with large archives simply have nothing to work with. Stephen Houston called it a secure example of Olmec writing. He also admitted plainly that we cannot read it. It pushed the birth of literacy in the Americas back by centuries, and then it went quiet. Number 3. Proto Elamite. If you want the title holder, the single oldest undeciphered writing system on Earth, this is it. Proto Elamite was used in what is now Iran between roughly 3100 and 2900 BCE. That is more than 5,000 years ago, at the very dawn of recorded human thought. And here is the irony. This was an accounting system. It was built to make things clear, to track who owed what. Today, it is almost completely opaque. Around 1,600 tablets survive, the great majority from the ancient city of Susa, with others from sites including Tepe Sialk, Tepe Yahya, and Shahr-i Sokta. They are administrative records, dry as dust in their purpose. They count livestock, grain, rations, and labor. Proto Elamite emerged right after, and was almost certainly inspired by, the proto-cuneiform writing of the neighboring city of Uruk in Mesopotamia. But the people of Susa did not simply copy their neighbors. They adapted the idea into something local and distinct. The system uses more than 1,000 distinct signs, mixing numerals with pictographic and abstract symbols. And we have actually made real progress on part of it. The scholars Peter Damerow and Robert England decoded several of the numerical systems, showing that Proto-Elamite scribes used different counting methods for different kinds of goods. Discrete objects counted one way, measures of grain another. They even used a place value-like notation, an accounting innovation thousands of years early. The problem is everything that is not in number. The signs that record the actual goods and the actual names of people, the heart of the message, remain unread. Part of the reason is that the scribes made a lot of mistakes. The system was young and not yet standardized, so the same idea might be written several different ways, which is a nightmare for anyone trying to find patterns. The modern effort has been led by Jacob Dahl at the University of Oxford, working through the Cuneiform Digital Library Initiative. In 2012, his team built a special imaging rig using a technique called reflectance transformation imaging, which lights an object from many angles to reveal faint marks. They photographed the tablets in extraordinary detail and put them online, inviting the public to help. The effort drew international attention, and still the script held. There is no bilingual inscription to anchor it. The language underneath may be an early ancestor of Elamite, which is itself a language isolate, related to nothing else we know. Proto Elamite vanished around 2900 BCE. Centuries later, a completely separate system called Linear Elamite appeared, and in the last few years, a team led by François Dessay announced major progress reading that one, using inscribed silver vessels. But that is a different script. Proto Elamite, the oldest of them all, stays locked. The dry little ledgers of Susa are still counting something. We just do not know what. Number 4. The Byblos Syllabary. Some scripts are mysteries because of where they sit in history, caught in the gap between two worlds. The Byblos Syllabary is one of those. It comes from the ancient port city of Byblos, modern Jbeil, on the coast of Lebanon, and it is sometimes called pseudo-hieroglyphic because, at a glance, the signs look like Egyptian hieroglyphs. They are not. They only resemble them. The script dates to roughly the first half of the second millennium BCE, somewhere between 1800 and 1400 BCE. It was discovered by the French archaeologist Maurice Dunon, who excavated Byblos starting in the 1920s and published the inscriptions in 1945. The corpus is tiny, only about 10 primary inscriptions, carved or cast onto bronze tablets, bronze spatulas, and stone. That scarcity is the whole problem, but we will get to that. The signs number somewhere between 90 and 114, depending on who is counting. That figure matters enormously. It is too many to be an alphabet, which usually has a few dozen letters, and too few to be a full picture writing system with thousands of signs. A count in that range almost always means a syllabary, where each sign stands for a syllable, a consonant plus a vowel. Why should anyone care about 10 short texts from one Lebanese town? Because of where Byblos stood. It was the great hub of trade between Egypt and the Levant, shipping cedarwood out and bringing Egyptian papyrus in. In fact, the Greek name for the city, Byblos, gave us the word for papyrus, and through that, the word Bible itself. And Byblos is also the home of the later Phoenician alphabet, the ancestor of the very letters you are reading right now. So this strange syllabary may sit at one of the most important crossroads in the history of writing, between the hieroglyphs of Egypt and the alphabet that would conquer the world. People have tried to crack it. The scholar Edward Dorm proposed a decipherment in 1946, reading the texts as an early form of Phoenician. George Mendenhall offered another attempt in 1985. Neither has been accepted. The presumed language is a Northwest Semitic tongue, an early relative of Phoenician and Canaanite, which we actually know fairly well. So, why can we not read it? The answer is brutal arithmetic. With only 10 short inscriptions, there is simply not enough text to test any theory. You propose a sound for a sign, and you have nowhere near enough examples to confirm or disprove it. There is no accepted bilingual. And the resemblance to Egyptian hieroglyphs, far from helping, is a trap because the signs were borrowed in shape but given entirely different values. Byblos was experimenting with writing, perhaps even inventing a prestige script to rival Egypt and Mesopotamia, in the very centuries before the alphabet made all of this effort obsolete. Number 5. Cypro Minoan. Stay in the eastern Mediterranean, but move to an island and to a script defeated not by a lost language, but by simple scarcity. Cypro Minoan is the Bronze Age writing of Cyprus, used from about 1550 to 1050 BCE. The name was coined by the British archaeologist Sir Arthur Evans, who believed it grew out of the Minoan writing he had found on Crete. The entire surviving corpus is only around 200 to 250 inscribed objects, and many of those carry just a handful of signs. The objects are an odd mix. There are clay tablets, cylinder seals, votive items, inscribed pottery, and, most curiously, hundreds of small clay balls, each about the size of a marble, each stamped with a short sequence of signs. Nobody is certain what the clay balls were for. Tokens, perhaps. Labels. Names. The longest connected text, a tablet from the site of Encomi, is still short by the standards of any decipherment. The French scholar Emilia Masson, in the 1970s, divided the material into 3 sub-varieties she called CM1, CM2, and CM3. But that very division is now contested. The scholar Silvia Ferrara, whose 2-volume study from 2012 and 2013 is the modern standard, argues that the subdivisions are overstated and that the system is more unified than Masson thought. When experts cannot even agree on how many scripts they are looking at, you can sense how thin the ground is. Here's the tantalizing part. Cypro Minoan likely descends from Cretan Linear A, and it is almost certainly the ancestor of a later script called the Cypriot Syllabary. And that later script we can read because it was used to write Greek, and there was a bilingual to crack it. So scholars can look at a Cypro Minoan sign, find a similar looking sign in the readable later syllabary, and guess at its sound. The trouble is that back-projecting values across 500 years is deeply unreliable. Signs change. Sounds drift. The underlying language is unknown. It may be something called Etio-Cypriot, a non-Greek, non-Semitic language that shows up later in the readable script, related to nothing else. Cyprus in this era was a wealthy place, known to the Egyptians and Hittites as Alashia, a major exporter of copper mentioned in the famous Amarna letters. Its merchants and officials clearly wrote things down across the whole island, but the texts are too short, too few, and too fragmentary. There is no bilingual. And so most specialists say plainly that Cypro Minoan cannot be deciphered without a major new discovery, a longer text waiting somewhere in the Cypriot soil. Number 6. The Phaistos Disc. Now we come to perhaps the most famous mystery object on this entire list, and one of the most maddening, because it should not exist as early as it does. In 1908, the Italian archaeologist Luigi Pernier was digging in the Minoan palace of Phaistos on the southern coast of Crete when he found a small disc of fired clay. It is about 16 centimeters across and 2 centimeters thick. Its archaeological context dates it to around 1700 BCE, though even that is debated. Both faces are covered, edge to center, with a spiral of symbols. There are 241 of them in total, and here is the astonishing detail. Each symbol was not drawn by hand. It was stamped into the wet clay using individual punches, like little rubber stamps, one per sign. That makes the Phaistos Disc arguably the earliest known example of movable type printing in human history, predating Johannes Gutenberg and his printing press by roughly 3,000 years. Someone in Bronze Age Crete had a set of reusable type, which means they intended to print this text more than once. The signs themselves are vivid pictures. There are 45 distinct types. They include a crested human head with what looks like a mohawk of feathers, a walking child, a woman, a fish, a flower, a shield, and a bird in flight. Vertical lines divide the spiral into 61 groups, which most scholars treat as words, 31 on one side and 30 on the other. A sign count of 45 again points to a syllabary. So why can we not read it? Because of that intention to print more than once, which was apparently never fulfilled. This is the only object like it in the world. There is nothing to compare it against. The reused punches prove a writing system existed, and then every other example of it vanished or was never made. A single Minoan bronze axe, found at Arkalakori, carries a few signs that resemble the disc's symbols, and that is the only parallel anyone has ever found. It is far too short to help. The reading direction is debated, though most argue you follow the spiral inward from the rim. Decipherment claims have been endless. People have read it as a prayer to a goddess, a hymn, a list of place names, a calendar, even a board game. None of these readings is accepted. The scholars Gareth Owens and John Coleman have proposed partial phonetic values, suggesting a few words such as a Minoan term for a goddess, but these remain speculative. There is even a darker doubt. In 2008, the researcher Jerome Eisenberg argued the disc is a modern forgery, made in 1908. Most specialists reject this, but the claim lingers, partly because the Greek authorities have never permitted thermoluminescence testing, which could date when the clay was actually fired, and settle the question for good. The presumed language is Minoan, the same unknown tongue behind Linear A. And that brings us to the cruelest case of all. Number 7. Linear A. Imagine a script you can read aloud, sign by sign, sound by sound, and yet not understand a single word you are saying. That is Linear A, and it is one of the strangest situations in the entire study of writing. Linear A was the script of the Minoan civilization of Crete, used from about 1800 to 1450 BCE. It was named by Sir Arthur Evans during his excavations at Knossos, beginning in 1900, to set it apart from a later script he called Linear B. The corpus is comparatively rich, around 1,400 inscriptions, though most are short administrative tablets. They have been found across Crete and at other Aegean sites, including the island of Thera, which we now call Santorini. Many of these tablets survived only because the fires that destroyed the Minoan palaces baked the soft clay rock hard, preserving the writing of bureaucrats who never meant their notes to last. Now here is the twist that makes Linear A so painful. Its successor, Linear B, was famously deciphered in 1952 by a young English architect named Michael Ventris, working with the scholar John Chadwick. Ventris cracked it without a bilingual, using sheer pattern analysis, and discovered that Linear B recorded an early form of Greek. And because Linear B clearly evolved from Linear A, sharing dozens of nearly identical sign shapes, scholars can take the known sound values of Linear B and apply them to Linear A. When you do that, you can pronounce Linear A. The words come out of your mouth, but the language they form is not Greek. It is not any language we recognize. Scholars call it Minoan, or Ediocraton, and it remains completely unidentified, possibly a language isolate with no living relatives. So we have a script that is phonetically readable, but linguistically silent. We can say the words, we just have no idea what they mean. The system uses around 90 syllabic signs, plus logograms, whole word symbols for commodities like grain, wine, oil, and figs. The numerals are partly understood, including a surprisingly sophisticated set of fraction signs. One word, often written as asasarame, recurs on stone libation tables used in religious ritual, and many suspect it is the name of a deity or a sacred dedication. The scholar John Younger maintains an authoritative online corpus of every known text. But there is no bilingual. The texts are mostly short lists. Researchers have tried to link Minoan to the Anatolian language Luwian, to Semitic languages, and to others, with no consensus. Linear A use ended around 1450 BCE, when the palaces fell and the Mycenaean Greeks took over, bringing their own Linear B. To truly read Linear A, to understand it rather than merely pronounce it, would almost certainly require a substantial bilingual text. None has ever been found. The Minoans are speaking to us, clearly and aloud, and we cannot understand a word. Number 8. the Indus Valley script. We end with the largest civilization of them all, and a script so brief that some scholars argue it is not writing at all. The Indus Valley, or Harappan, civilization flourished across what is now Pakistan and northwest India from about 2600 to 1900 BCE. Its great cities, Harappa, Mohenjo-daro, Dholavira, and Rakhigarhi, were marvels of urban planning, with grid streets and advanced drainage supporting a population that may have reached 1 million people. And these 1 million people left us thousands of inscriptions that we still cannot read. There are roughly 4,000 to 5,000 inscribed objects, the majority of them small square seals, carved from steatite, a soft stone. The first was published by Alexander Cunningham back in the 1870s, but serious study began with the great excavations of the 1920s, led by John Marshall and his colleagues Rakal Das Banerjee and Dayaram Sani. Here is the central obstacle, and it is a severe one. The texts are astonishingly short. The average inscription is only about 5 signs long. The longest text on any single surface is just 17 signs. There are between 400 and 700 distinct signs, depending on the analyst, a count that points to a Logos Syllabary, a mix of word signs and syllable signs. The writing generally runs from right to left. A typical seal pairs a short line of signs with the image of an animal, most famously a one-horned bull, often called the unicorn, standing before a ritual offering stand. The decipherment effort has been enormous and is deeply contested. The Finnish scholar Asko Parpola has spent decades compiling the corpus and arguing that the underlying language is Dravidian, the family spoken across southern India today. He has proposed, for instance, that a fish sign could represent a Dravidian word that means both fish and star. The Indian scholar Iravatha Mahadevan produced a foundational concordance of the signs in 1977. Then, in 2004, 3 researchers, Steve Farmer, Richard Sproat, and Michael Witzel, dropped a bombshell. They argued that the Indus script is not writing at all, but a system of non-linguistic symbols, more like heraldic emblems than recorded speech. Their evidence was the extreme shortness of the texts, the total absence of any long inscription, and statistical patterns in how the signs appear. The claim ignited a furious debate. In 2009, the computational scientist Rajesh Rao and his colleagues fired back in the journal Science, using a measure called conditional entropy to argue that the sign sequences behave statistically like a real language. No bilingual has ever been found. The script vanished with the decline of the Indus cities around 1900 BCE, a collapse likely tied to climate change and the drying of a great river system. It has no confirmed descendant. And because the underlying language touches on charged questions about Dravidian versus Indo-Aryan origins in South Asia, the decipherment is not only a scientific puzzle, but a political one. After more than a century of effort, and now machine learning thrown at the problem, there is still no reading anyone agrees on. Step back from the 8, and patterns begin to emerge in how a script goes silent. The first and most violent is demographic catastrophe. Rongorongo died because the people who could read it were carried off in slave raids and killed by disease. When a society's literate class is destroyed faster than it can teach the next generation, the key vanishes in a single lifetime. The same kind of rupture, on a larger scale, ended writing traditions across the world. The second killer is a tiny corpus. The Byblos Syllabary survives in about 10 inscriptions, Cypro Minoan in a couple hundred short ones, the Phaistos Disc in exactly 1 object. Decipherment is, at heart, a problem of patterns, and patterns need repetition. With only a handful of texts, you cannot test a single guess, because there is nothing to check it against. A unique object, like the disc or the Cascajal Block, is the worst case of all. There is literally nothing in the world to compare it to. The third killer is short texts. The Indus script may encode a real language, but with an average of 5 signs per inscription, it offers none of the long, redundant sentences where grammar reveals itself. Administrative records, like the Proto Elamite ledgers, suffer the same way. Lists of quantities do not contain the connective tissue of speech. And the fourth, subtlest killer, is a lost language. Linear A shows that you can have plenty of readable signs and still understand nothing, because the words themselves belong to a tongue that died without descendants. The same wall blocks Cypro Minoan, whose Indo-Cypriot language is related to nothing we know, and Proto Elamite, whose tongue may be an ancestor of the isolate Elamite. There is a fifth factor that quietly worsens all the others: the loss of descendants. Most living scripts can be traced backward through a chain of ancestors, and that chain is itself a tool. We read the later Cypriot syllabary, so we can guess at Cypro Minoan. We read Greek, so Ventris could crack Linear B. But the Indus script, the Cascajal Block, and the Phaistos Disc left no children at all. The line was cut, and with it went the thread we might have followed back. Running through every one of these 8 cases is a single missing ingredient. There is no bilingual, no Rosetta Stone, no passage written in both the lost script and a language we already know. That one absence, more than anything else, is why these scripts keep their secrets. So how does anyone ever crack a lost script? It helps to know what has worked, because it shows exactly what these 8 are missing. The most famous tool is the bilingual. The Rosetta Stone, carrying the same decree in Egyptian hieroglyphs, Egyptian Demotic, and Greek, let Jean-François Champollion break hieroglyphs in 1822. A similar trilingual glyph carving at Behistun in Persia let Henry Rawlinson unlock cuneiform. When you can line up the unknown against the known, the door opens. But a bilingual is not the only path. Michael Ventris cracked Linear B in 1952 with no bilingual at all. Instead, he built a grid, mapping which signs shared vowels and which shared consonants based on how they patterned, and then made an inspired guess that certain sign groups were the names of Cretan towns. Once those place names fit, the whole system unraveled, and the language turned out to be Greek. That last point is crucial. Ventris succeeded partly because the hidden language was one we already knew. Other tools fill the kit. Counting the distinct signs tells you whether you're looking at an alphabet, a syllabary, or a logographic system. Studying how signs crowd at the edges reveals the direction of writing. Recurring formulas, like dedications or accounting headers, give anchors. Identifying numbers and units of measure provides fixed points. The decipherment of Maya glyphs came when Yuri Knorozov insisted the signs were partly phonetic and tested them against living Mayan languages. Now, look back at our 8. Each one is missing at least one essential ingredient. The Phaistos Disc has no second example. Linear A has readable signs, but an unknown language. The Indus script has texts too short to analyze. Proto Elamite has errors and no bilingual. The decipherer's dilemma is always the same. You can have the signs without the language, or the language without enough signs. You almost never get both. And without both, the wall holds. In the last 2 decades, a new kind of decipherer has entered the field: the computer. The hope is obvious. If the obstacle is finding patterns across thousands of signs, surely a machine can do what a human eye cannot. The reality has been more humbling. Jacob Dahl's team used reflectance transformation imaging to capture Proto Elamite tablets in stunning detail, and then crowdsourced readings online, putting the puzzle in front of thousands of eyes. It refined the corpus, but it did not crack the code. The most famous computational episode involves the Indus script. In 2009, Rajesh Rao and colleagues applied a measure called conditional entropy, essentially asking how predictable the next sign is given the previous one. Languages have a characteristic middle range of predictability, more structured than random, less rigid than a frozen list. The Indus sequences fell into that linguistic range, which the team argued was evidence the script encodes a real language. Critics replied that statistics alone cannot prove language, and the debate continues. Machine learning has since been trained to classify signs, cluster similar shapes, and even attempt automated decipherment of lost languages, with researchers at institutions like MIT demonstrating systems that can rederive known scripts, such as Linear B. Three-dimensional scanning recovers worn marks invisible to the naked eye. Digital corpora, from the Cuneiform Digital Library to John Younger's Linear A archive to Sylvia Ferrara's Cypro Minoan catalog, put every known text within instant reach of any scholar on Earth. And yet the fundamental limit remains. Modern machine learning is hungry for data, and these scripts are starving it. You cannot train a powerful model on the single Phaistos Disc or on 10 Byblos inscriptions. There is also a real danger that computation produces a decipherment that is really just a pattern illusion, a structure the algorithm imposed rather than found. Computers have narrowed the possibilities and sharpened the questions, but the human epigrapher, reasoning carefully from context, is still the one who has to make the final leap. And so far, on these 8, no one has. There is a question lurking underneath several of these mysteries, and it is more unsettling than it first appears. What if some of these scripts are not writing at all? To answer that, you have to define what writing even is. The strict definition is that true writing encodes speech, that the signs stand for the sounds or words of a spoken language. A looser idea, sometimes called proto-writing, is a system that conveys meaning without recording language, the way a road sign or a tally mark does. This is the heart of the Indus controversy. When Farmer, Sproat, and Witzel argued in 2004 that the Indus signs are not writing, they were saying the symbols might be emblems, religious or political markers, rather than recorded sentences. Their evidence was the brevity of the texts and the way certain signs cluster. If they are right, then there is nothing to decipher, because there is no language hidden inside. The same doubt has been raised about Rongorongo. Is it a script or a memory aid that prompts chants the reader already knew? The size of the sign inventory feeds the argument. A system with a few dozen signs is probably phonetic. A system with hundreds may be logographic, or may not be language at all. The internal structure matters too. The Cascajal Block earned its claim to true writing because its signs repeat and sequence in patterned ways. Standardization, the sense that scribes agreed on how to write things, is another clue that a language is being encoded. The honest position is humility. Imposing modern assumptions about what writing should look like has misled scholars before. These systems emerged at the very boundary between symbol and speech, in the centuries when humanity was still inventing the idea of writing itself. The line between an accountant's tally and a true sentence was being drawn for the first time, and some of these 8 may sit right on top of it. What would settle the question is the same thing that would crack the code: a long text with enough internal variety to reveal grammar. And that is exactly what none of these 8 ancient scripts has ever managed to give us. Each of these 8 scripts is a civilization trying to speak to us in a language we cannot hear. That is the strange, almost haunting fact at the center of all of them. The Minoans of Crete are talking aloud through Linear A, and we cannot understand them. 1 million Harappans press their words into clay, and the words sit there, mute. The readers of Easter Island chanted their tablets, and then the chanting stopped forever. But these silences are not necessarily permanent. The history of decipherment is, above all, a history of luck. A single new discovery, one longer tablet, one bilingual buried in the right ruin, could change everything overnight. We have a recent reminder of this. Linear Elamite, a cousin of Proto Elamite that resisted scholars for over a century, has in the last few years yielded much of its meaning, thanks to a handful of inscribed objects that gave researchers the anchor they needed. What seemed hopeless became readable. It is worth pausing on what we actually lose when a script stays dark. These are not just sign systems. They are laws, prayers, names, accounts, perhaps poems. They are the recorded thoughts of people who wanted to be remembered and who took the trouble to write things down precisely so that they would not be forgotten. Their fragility is a quiet warning. Writing feels permanent, but literacy is a living tradition, and traditions can die in a single generation. So the next time you see one of these objects in a museum case, a spiral-stamped disc, a tiny carved seal, a slab of green stone from a Mexican quarry, understand what you are looking at. It is a message that arrived intact across thousands of years, perfectly preserved and still sealed. We have the letter. We simply cannot open it. And somewhere, in the soil of Crete, or the Indus Plain, or a Lebanese harbor, the key may still be waiting for the person patient enough to find it.